Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 6 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a polygon. They don't even tell us what it is. It's just a random polygon. It's going to be dilated to create a smaller polygon. And then we need to find the rule. Well, let's draw something. Let's just put a coordinate grid here. Let's just see what would happen if we do some of these things. So polygon. All right, well, they're not going to give it to us. So let's just kind of make a triangle. I guess we could just kind of make that triangle right there. All right, so what are we going to do here with these options here? Well, look at this one right here. We've got 0.5, so that's probably going to make something smaller, we think. But look at this. We've got negative x and negative y. So what actually happens? Well, if you wanted to, right, you could actually, create some points here for this if you really wanted to, right? So you can say, let's say this is 0, let's call it 3, and let's call this negative 5, 3, and let's call that negative 2.5 and negative 0.5, right? If you wanted to, what we could do is you can actually plug these points into this right here. But if you remember from your transformations, something happens when you do negative x, negative y. That's actually a rotation. When you start making the x and the y negative, you actually rotate. So this is actually a rotation of 180 degrees. So what we're going to do is we're going to take this, and it's just going to end up kind of rotating it down like this. Okay, and so that's what happens when you get a negative x and negative y. And the only difference is we've got 0.5 minus x and 0.5 minus y. So it's going to rotate it, and then it's going to slide it a little bit, right? It's going to slide it over and up just a little bit, just a hair. But it's going to keep the exact same shape. It is going to rotate it, so it's going to have a different orientation, but it's going to be the exact same size. And we're looking for something that is smaller. So negative x and negative y, that's a little bit of a rotation with a translation thrown in there. Right, that's a little bit of a slide and a rotation, but we're looking for a dilation. We're looking for something to make it smaller. So x minus 7, y minus 7. Notice our x and our y both stay positive. So this is just a pure translation. So we're just going to slide this thing. It's going to go down 7, and it's going to go left 7. So we'll go left 7, down 7. So it's going to end up being a slide just down there, but same orientation, same size. But we're not looking for that. We're looking for a smaller. So here's something. Whenever we're dealing with dilation, you always use a scale factor. And this word factor should be something that you remember even from 3rd grade. It has to do with multiplication. So we need to multiply. That's what we have for our two answer selections in H and J. But when your scale factor is less than 1, then you get something that is smaller. That's what we're looking for. If your scale factor is greater than 1, it's 5, it's 2, it's 3.5, then it becomes larger. And that makes sense. When you multiply a number by a number that's greater than 1, it becomes larger. If you multiply a number by a number that's smaller than 1, it becomes smaller. Right? Multiplying something by half makes it half as big. So all we need to do is evaluate our two factors, right? So 5/4 is greater than 1, which means it's going to become larger. 0.9 is just barely, but it's less than 1, which means it's going to be smaller, and that's the one we're looking for. So our answer here is J.